Well, let's identify, let's try another example of graphing a conic and finding its vertices and foci. What we have right here is appears to be either an ellipse or a hyperbola. As I discussed in the past tutorial, is that you identify if it's an ellipse or hyperbola by identifying the terms and if it's a plus or minus. And we notice that right here it is a plus, so this is going to be ellipse. Okay, so it's elliptical. Now from here, the ellipse, we're going to identify some different things. So we can actually, it's already in the standard form of an ellipse. So we want to identify then now, just go through, and so we can graph it, different aspects of it. First off, I want to find the center. So from here, we're going to find the h and k. Well, the center, we look at here and here. And we notice that the x value, x plus 3, so it's going to be negative 3. And then we notice that y minus 2, so it's going to be 2. So we have negative 3 and 2. So we go over here, and we're going to graph this out. I'll put it in blue. All right. And we're going to go negative 3 and 2. So 1, 2, 3, 1, 2, and here's our center. Now, from here, the next thing we want to do is I want to identify our major axis. Okay. Now, our major axis is determined whether or not a squared has to be larger than b squared. The a is always our major axis. So we compare our two different values. Well, we see 16 and 12. Well, 16 is definitely going to be greater than 12. So this right here is our a squared. So our major axis is actually going to be vertical. So that means when we graph this out, we want to have our major axis is going to go down like this. Okay, so this is where our foci are going to be in our vertices. The next thing is we want to figure out what our a values, so find our vertices. Once we find our major axis, I guess now the next thing is our vertices. And then recall that our vertices are always a units from the center on the major axis, right? On major. So in this case, we have 16 is a squared. And so a is going to equal 4. So our vertices are going to be 4 units. All right, I'm going to go up 4, 1, 2, 3, 4. So we have vertice 1, 1, and we'll label that as negative 3. And we went up 4 vertically, so that'd be 6. We also go from here, is we're going to go down 4 as well. So we go 1, 2, 3, 4. It appears to be right there. It's going to be vertice 2, and vertice 2 is going to be negative 3. And we're going down 4 from there, so it'll be negative 2. Okay, so that's vertice 2. Now, we're going to graph this out. The next thing, if we want to finish our graph, is to find the b value. Okay, the b value. And we want to find the minor axis. Okay, the minor axis is the b value. It's b units from the center. So b squared, in this case, is 12. So b is going to equal the square root of 12, which is the same thing as 2 squared root of 3. Well, we can wrap that out, and 2 squared root of 3 is going to be about 3.5 something, 3.5, 3.46. Using your calculator, you can figure that out. All right, so it's about 3.46. 3.46. You can see that. You probably can't, but in any case, we're going to go 3.4 units to the right and left from the center. So this is going to be a minor axis. So 1, 2, 3, and a little bit more. So about right there. All right, I'm going to go 1, 2, 3, and a little bit more. About right there. And we can kind of just draw this out around. And this is horrible because obviously my units are not uniform. Ah, well. Okay, so, but that's going to be our sketch of our ellipse. We're going to finish this off by finding our foci, or foci, I don't know how he says it. Now to find the foci, foci are on the major axis as well, and are c units away. Because remember the c value, it's c units away. And we're going to use this equation, c squared for an ellipse is equal to a squared minus b squared. Well, here we're going to find that by taking our values, and our 16 minus 12 equals c squared. C squared is going to equal 4. So c equals 2. Okay, c equals 2. So from here, we're going to be going from the center 2 units up, 1, and 2 units down, 2, and we can write those out. So focus 1 is going to be -3 and 4, and our focus 2 is going to be -3 and 0. Okay, and we found that. And just so you know, and I did say another one, when we have this, the reason why we have these foci are that when we take any point on here, we're going to go right there, the distance from the foci, all right, this is D1, all right, to here, we'll call it D2. From those two, if you add D1 plus D2, that will be uniform to any point on the graph. So when we go over here, that and that, those two values would be equal to any point, fixed point on the graph itself. So D1 plus D2, that's why we're doing it. Okay, so hopefully this helps you out. A little bit easier example, but once again, going through the different process of how to graph and find the vertices and foci of the ellipse. Key thing is you want to get into standard form. You want to find the center first, then identify the major axis by looking at the A value. Whatever the larger value is, that's where you find the major axis. In this case, the major axis was on the A value. The larger value was under the Y, so it's going to be a vertical, all right, axis or major axis. You then find the A value to find the vertices, all right, because it's from the center A units away. Then you can finish up the drawing by finding the minor axis, which is B units from the center. And then finally, find the foci, or each individual focus, by going along the major axis and using this little formula right here, c squared equals a squared minus b squared to find that c value, and you can graph it out. We also finished up by discussing this right here. The definition of an ellipse is where the distance from one focus to a point on the ellipse plus the distance from the other focus to another point on the ellipse, those will be uniform at any point on the ellipse itself. Okay, so hope that helps you out, and we'll have another example on an application in our next tutorial.